Let us see the answers. First, bond formation Cl2. So chlorine, what is the atomic number? 17. So what will be the electronic configuration for chlorine? 2, 8, 7. So now, how many electrons chlorine required to be stable? 1 electron in its valence shell. After gaining 1 electron, it will acquire a nearest noble gas argon's electronic configuration and it will become stable. But for that, it needs 1 electron. So when a chlorine form a covalent bond with another chlorine atom, first we will write 2 chlorine atom, then we will write only 7 valence electron. So here it will be 1, 2, 3, 4, 5 and 6. Here the 7th one will be in sharing. These are the electrons of another chlorine atom, 7. So this electrons will be shared. So I am just drawing a Venn diagram where these 2 electrons will behave as if it is for this chlorine atom and these 2 electrons will behave as if it is for this chlorine atom. So in turn, both the chlorine atom will complete its octet. If you will see the 8 electrons, then 8 electrons is for this chlorine atom and 8 electrons are there for this chlorine atom. So it will form chlorine covalent bond, in turn it will be chlorine molecule. 2 chlorine atom will form 1 chlorine molecule. Remember, when 1 pair of electron is being shared, it is forming 1 single bond. When 2 pair of electrons are being shared, there will be double bond. And when there are 3 pairs of electrons are being shared, there will be triple bond formation in covalent bond. Let us see another example. Bond formation for methane. As I have said, 1 carbon will form 4 different covalent bonds with 4 different hydrogen atoms. So first we'll write a carbon. Carbon's atomic number is 6. So electronic configuration will be 2, 4. In this, if you have any doubt how to write electronic configuration and how any atom will acquire a nearest noble gas electronic configuration, please refer to my video Electronic Configuration of Elements. Now carbon's atomic number is 6, its electronic configuration is 2, 4. Now we will write about hydrogen. As we know, its atomic number is 1 and it is having only 1 electron in its valence shell. So to complete its octet, carbon requires 4 more electrons and it will follow nearest noble gas neon's electronic configuration. Here it wants only 1 electron to complete its outermost shell and it will follow duplet rule just like helium. So as I have seen, carbon will be in the middle and the 4 hydrogen atom will be in surrounding of carbon atom. So here carbons I am writing only the valence shell electron. So one electron from carbon and one electron from hydrogen. Just to separate the electrons, I have marked cross electrons for hydrogen and dot electron for carbon. So now we will just draw a Venn diagram to show how the electrons are being shared. So if you will see that two electrons are being shared, 1 pair of electrons, and this hydrogen will complete its duplet, this hydrogen will complete its duplet, this and same with this hydrogen and this hydrogen. Now if you will see the middle carbon atom, then it will complete its octet 1, 2, 3, 4, 5, 6, 7, 8. So carbon will complete its octet, whereas all the hydrogen will complete its duplet. So in turn it will be a covalent bond between carbon and 4 different hydrogen atoms. So here our molecule is methane, where there is a formation of 4 covalent bond in between carbon and hydrogen. Now we will see another example in covalent compound, that is water molecule. Water molecule's molecular formula is H2O, and it forms 2 covalent bond with 2 different hydrogen molecule atoms. So one hydrogen atoms, its valence electron 1, oxygen atom, its 6 valence electron, and hydrogen atom, its 1 valence electron. So they are forming 2 covalent bond. 1 electron from hydrogen and 1 electron from oxygen is being shared. Here also 1 electron is being shared. And 1 covalent bond and another covalent bond is formed between 2 hydrogen atom and 1 oxygen atom. If you will see here that 1 pair of electron and this another pair of electron are being unused. This pair of electrons are known as lone pair of electron. This unused pairs are known as lone pairs of electron, and there are 2 unused pairs of electrons, and this 2 unused pair of lone pair of electrons are responsible for forming a co-ordinate covalent bond. Now, what is co-ordinate covalent bond? It is a type of covalent bond, but a bond in which one atom contributing both of the shared electron. How? That when any 2 atoms are sharing electron, they are contributing equally. If you will see here, this hydrogen and this electron, 1 electron is being shared by hydrogen and another electron is being shared by oxygen. So they both atoms are sharing electrons equally. But when the one atom is contributing both the shared electron, that means to forming a 1 bond we need 2 electrons. But to form a 1 bond, both the electrons coming from only 1 atom, that kind of bond is known as coordinate covalent bond. Now we will see an example regarding that. That is formation of H3O plus ion. This is known as hydronium ion. So here it's our water molecule, and this is H plus ion. How this is H plus ion? That hydrogen has 1 valence electron. Its electronic configuration is 1. When hydrogen atom is losing its 1 electron, it is forming H plus ion. That H plus ion is attracted towards this unused pair of electron. So this H plus ion is attracted towards this 2 electrons, and it is forming a bond between oxygen and hydrogen. If you can see here that this is a covalent bond, this is also a normal covalent bond, but this bond is being formed by both the electrons of oxygen, because when this hydrogen is being combined with this H2O molecule, it doesn't have any electrons. It is H plus. Whatever electron was there, it has lost it. So it is H plus. When it loses 1 electron, it gains plus charge. So H plus ion, when it is combined with this oxygen, for this covalent bond formation, both the electrons are being used from oxygen. So this bond is known as coordinate covalent bond, and we have to denote it like in the sign of arrow, that oxygen is giving its both the electron. Oxygen is giving its lone pair to H plus ion to form a hydronium ion. So that's why this is, for this ion we have to put this plus charge, because H plus ion has been combined over here and this lone pair is being used to make a coordinate covalent bond. So again, what is a coordinate covalent bond? That one atom contributing both of the shared electron. That means one atom is contributing for a covalent bond and both the electron is being used for this covalent bond, and this both the electrons oxygen only is giving. There is no contribution from the side of H plus ion. So this is known as coordinate covalent bond. Now one more ion formation is there, that is formation of hydroxyl ion, that is OH minus ion. How this is happening? Again, this is our water molecule. Hydrogen and hydrogen, there are two covalent bonds. When this water molecule, from this water molecule, when one hydrogen is going away, it is breaking a bond, and this H plus ion is breaking a bond and going away, then the entire ion, that negative charge will be generated, because when H plus will go, it goes along with the plus charge. It is not taking any electron. Whatever electron it has shared, it leaves along with hydroxyl ion and it goes with plus charge. So for entire hydroxyl ion we have to put minus charge, because if you can see, there are three unused pair of electrons are there. So this is OH minus ion. This is H plus, which has separated from H2O molecule. So this is our hydroxyl ion. We have to put here minus charge, and this is H plus. So from formation of water molecule, we have seen here three different types of bond formation. First, a normal covalent bond in between oxygen and hydrogen, two hydrogen atoms. Then because of the lone pairs are there, H plus will be attracted towards this lone pair, unused lone pair, and they are forming hydronium ion, H3O plus, and this is known as coordinate covalent bond. The one atom contributing both of the shared electrons. Then formation of hydroxyl ion. How this can happen? From the water molecule, H plus ion is separated, leaving behind the negative charge. This is hydroxyl ion. Now for your practice, just try a formation of NH4 plus ion. This is ammonium ion. This is also an example of coordinate covalent bond. Just try it yourself and see. Now we will see a difference between non-polar covalent compound and polar covalent compound. Earlier we have seen a covalent compound. What is a covalent compound? A compound which formed due to a sharing of electrons between two atoms is a covalent compound. So in covalent compound there are two types of compound. One is polar, another one is a non-polar. Now what will happen in non-polar covalent compound? Shared pair of electrons are equally distributed, that is non-polar. Whatever electrons are being shared among two atoms are equally distributed. Like those pair of electrons will be equidistant from both the atoms. Just like this. These two are hydrogen atoms and these two electrons are in the middle of those two. While this are equally distributed, means both are contributing equally and charge of that electron is also equally distributed. Where in polar covalent compound, what will happen? That shared pair of electrons are unequally distributed. They are unequal, means they are not in between the molecule, in between the atoms. It is slightly towards the atom which is more electronegative, and which atoms electronegativity is more compared to other atom. So here no charge separation, because electron is in middle of the both the atoms, so equally charge are distributed. No positive, no negative charge are separated. So no charge separation will be there in non-polar. Whereas here charge separation takes place. How? We will see that through this example. HCl is an example of polar covalent compound. Here hydrogen and chlorine are sharing electrons. Hydrogen will share one electron, chlorine will also share one electron. Hydrogen will complete its duplet, chlorine will complete its octet. But what will happen, that hydrogen is slightly positive whereas chlorine is slightly negative. Why? Because chlorine is more electronegative compared to hydrogen. So the electrons will be slightly shifted towards the chlorine. So what will happen, that slight positive, this is delta positive, it is partially charged. It is not complete charge formation. If it is complete charge formation, then it is an ion. An ion will be generally generated in electrovalent compound. This is covalent compound. So here in polar covalent compound, a partial charge will be developed because one atom is slightly less electronegative compared to other. Where chlorine is a halide, it is more electronegative compared to hydrogen. So slight charge, partial charge has been developed, and that we are showing with the help of delta. So when the electrons are slightly shifted towards chlorine, on hydrogen a slight positive charge will be generated, and on chlorine slight negative charge will be generated. If you will see something, it will look like this, that all electrons are little bit shifted towards chlorine and not towards the hydrogen. That's why partial charge formation will take place in polar covalent compound. So here no charge separation, and here charge separation takes place. This is the basic difference between non-polar covalent compound and polar covalent compound. We can see the example of hydrogen molecule, oxygen molecule, nitrogen molecule, chlorine molecule, methane and carbon tetrachloride. All these molecules are non-polar, means shared pair of electrons will be at equidistance and will be in middle of the atoms. It won't be shifted, and so the charge formation, partial charge formation will not be there in this. Whereas if you will see H2O, then hydrogen, oxygen, hydrogen, hydrogen plus delta and oxygen will be minus delta. Why? Because these are two electropositive and this is highly electronegative. So partial charge formation will be there. Whereas in nitrogen also, the lone pair of electron also will be there in oxygen. So the partial delta charge will, delta minus charge will be generated on oxygen. Whereas in nitrogen also, the lone pair of electrons will be there. So the partial charge will be generated on nitrogen and as well as on the hydrogen. So all hydrogen will be having a partially positive charge and nitrogen will be having partially negative charge. Whereas in HCl also, HCl a partial positive charge and partial negative charge will be generated. So all these are the polar covalent compound, whereas this are a non-polar covalent compound. Charge separation will be there and charge separation will not be there. Now we will see the difference between electrovalent compound and covalent compound. So generally electrovalent compound are crystalline hard solids, whereas covalent compounds are exist in all the three different states: gases, liquids and soft solid. So why there is a basic difference in their state, that these are the hard material, these are the soft solids and gases and liquid? The reason is the strong electrostatic force of attraction is acting between two atoms in electrovalent bond. As we have seen earlier, there will be a transfer of electron, there will be a charge formation, there will be an ion formation, and those positive and negative charge particle will come together. So there will be a more force of attraction. Whereas what will happen in covalent compound? A weak van der Waals force of attraction is acting between two atoms. That means the force of attraction is weak in covalent compound compared to electrovalent compound, because here whatever compounds are forming, they are formed due to sharing of electron. Here there is no ion formation will be there. So the force of attraction will be low compared to electrovalent compound. And because of the high force of attraction, the high melting point and boiling point will be there in electrovalent compound. The energy required to melt a solid and to boil a liquid will be high when the force is more. Whereas here a low melting point and low boiling point will be there because the force of attraction is less. They are good conductors of electricity and heat. When any electrovalent compound we are putting in a aqueous solution, they will dissociate into ion. For example, NaCl, a common salt, sodium chloride. When it is in a solid state, it cannot conduct electricity. But when for the same salt we will put in a water, it will dissociate into Na plus and Cl minus, and they can conduct electricity. So they are good conductors of electricity but not in a solid state. We have to dissociate the ions and only ion can conduct an electricity. So they always conduct electricity in molten state in aqueous solution. Here they are non-conductors of electricity because there won't be a charge formation, there won't be an ion formation. But one point is there that if it is a polar covalent compound, for example if it is an HCl, then if you are putting a few drops of HCl in water, then it will dissociate in H plus and Cl minus. So whenever you are thinking about covalent compound, you need to think about both the types of compound. One is a polar covalent compound and one is a non-polar covalent compound. Polar covalent compound are always show charge separation. So they can conduct electricity after the separation of the charge, but non-polar covalent compound cannot show charge separation. For example CH4 and carbon tetrachloride, they cannot conduct electricity because they cannot show a partial charge separation also. So they cannot conduct electricity, where a polar covalent compound shows charge separation. Now they can be electrolyzed because there will be a dissociation for the molecules will be there. If NaCl is there, then Na plus and Cl minus. So they can be electrolyzed, where here they cannot be electrolyzed. They are soluble in water. They are very well soluble in water because they are dissociated. So when we are putting in the water, they are easily soluble. Here solubility is only in the organic solvent. They cannot be soluble in the water, that means. Reaction is high speed. We need to understand that whenever the force of attraction is more, the combiner force is more, then reaction speed will be increased because fast they come together and they join and they form a molecule. So whenever Na plus and Cl minus will be there, immediately they will come together because of the opposite charge attraction and they form a molecule. So reaction will be always high speed, whereas here the reaction will be slow speed because the covalent compound formed through mutual sharing of the electron, and it will take some time for sharing of electron from mutual sharing of electron. So here the reaction will be slow speed. When these compounds are forming, the reaction for those compounds to form is slow, that means. Now undergo dissociation. As we have seen here, it will undergo dissociation. Means whenever you are putting any electrovalent compound in water, it dissociates into an ions, positive ions and negative ions. Whereas here they undergo ionization, and this is only for polar covalent compound and not for the non-polar covalent compound. Ionization means whenever you are taking HCl H plus and Cl minus will be generated. Ionization means it generates ion. Dissociation means you are breaking a molecule and you are generating an ion. So this is the basic difference between electrovalent compound and covalent compound. Tip to remember is, once you read this full difference, try to remember it and try to write it by yourself. You will remember all the points, and here there are 2-3 reasons also including into that. If in the exam they'll ask for the electrovalent compound, why there will be high melting and boiling point, or why in a covalent compound there will be a low melting and boiling point. So if you have remembered the full difference, then any of the reason if they'll ask, you will be able to answer it. So please see this, pause the video, try to write it by yourself. If you don't know anything, again you play a video and just try to remember all these short steps for big reasons.